Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy course, which is preparing you for the Cisco DEVASC 200-901 certification exam. We're going to be taking a look in this video at Lab 1.3.3, and I'm going to be breaking it down into several parts to make it a little bit more digestible. This is the Python programming review, and in this video what we're going to be covering is we're going to start to talk about the DEVASC Virtual Machine. We're going to talk about gathering some basic Python information. We're going to take a look at the interactive interpreter. We're going to look at the calculator functionality as well as some strings. And then I'm going to introduce you to VS Code as well as the Python.org Integrated Development Learning Environment, IDLE. And then we're going to go ahead and wrap things up. So let's go ahead and dive in by starting with the virtual machine for the course. Now, if you're watching this video and you're not taking the course, unfortunately, I cannot provide this software due to copyright restrictions. But as I commented in the course, you can actually complete everything that we're going to be doing for the first two labs in the course by using your native operating system, whether that's Mac OS or Windows. So, how do we get started? Well, the first thing we're going to want to do is we're going to want to pull up a terminal window, and you can do that by simply double-clicking this icon here. I actually have a window opened up with the text a little bit larger than it starts with the default to make it a little bit easier to see. And so the first thing we want to do is we want to check the version of Python that's installed on this virtual machine. Now, one of the common mistakes learners make is they'll simply type in Python and they'll do the -V in order to try to get the Python version. Now remember, that's a -V as an option there, and you'll see that we get this error message, but it also gives us some clues as to what we might really want to do. So remember, we're going to be using Python 3, and that's the version that we're interested in seeing. Now, you wouldn't want to use Python 2. Python 2 has not been supported in a little over 3 years, and so it's not going to help us here in this course. Everything we do in the course will be Python 3, and in fact, we're running Python version 3.8.2. Now, a quick note, the most recent version of Python is 3.11.2. However, everything that you need to do in the course, you're going to be able to do with Python 3.8.2, and right down here in the right-hand lower area, you can see they've got this sticker, Netacad DEVASC Virtual Machine, and it gives the build. So I actually downloaded the software yesterday, even though this virtual machine I've had for a couple of years, and it's the exact same image. So the image has not changed. So you're still going to be running Python 3.8.2. Now, could we do a sudo apt-get install Python 3? We certainly could. However, my recommendation for the course is to simply leave the software at 3.8.2. Again, if you're following along and you don't have the virtual machine, everything that we're doing you can do with other versions after 3.8. So 3.9, 3.10, 3.11, everything that you're going to see, you're going to be able to do. All right, well, let's dive into Python here, right? This is what this video is all about. So we'll say Python 3. Now, this is what's referred to as the interactive interpreter. And again, all this is going to do is allow us to type in Python code and see what's going to happen when we type that code in. A term that we need to be familiar with is REPL. And REPL is what the interactive interpreter is really doing. It's reading, it's evaluating, and some people say executing. So reading, evaluating, printing, and then looping, meaning it's just going to do the same thing over and over and over again. And that's what this interactive interpreter is all about. And so REPL, key term to remember there. So let's take a look at some simple things that we could do. We could do some addition. Whoops, I'm sorry. We could do some addition. We'll say 3 plus 3, we get 6. We could say 4 minus 2, and we're going to get 2. We can even do some multiplication. I can say 2 times 9, we get 18. We can do division. Now, the division always causes a little confusion initially. I could say 9 divided by 3, and you'll notice that we get a floating point number back. 3.0 with a decimal in there. Now, if we wanted to do floating point division, we would use a single forward slash. However, if I'm looking for integer division, I can go ahead and say 9 and then use 2 forward slashes and then the 3, and then we're going to get an integer back. And I'm going to show you how to confirm the actual data type that you're getting back in order to prove that yes, 3.0 is a float and 3 is simply an integer. Now, what we could also do is I could use exponents or exponentiation. I can say 2 to the 8, right? And we're thinking about maybe our subnetting days here, and we get 16. I'm sorry, 2 times 8, sorry about that. So we'll do 2 of the asterisks, and there we go. We get 256, right? So 2 to the 7, 2 raised to the power of 7, right? We're using exponentiation here. And what about 2 to the 6? Or 2 to the 5 should be 32. And there we go. So those are things that we can do. Now, something you need to be aware of, and maybe you remember from math class, if not, quick refresher here, is we're talking about PEMDAS, right? And PEMDAS, which is simply PEMDAS, stands for parentheses. And this is the order of operations as to how Python is going to handle sort of more complex mathematical equations that maybe you're going to be dropping in. So things that are in parentheses are going to be evaluated first, then exponentiation, then multiplication, then division, then addition, and then finally subtraction. And so let me give you an example of how we might do this or test that theory. So if I was to say 3 plus 3 times 3, we could look at this 2 different ways. Maybe I say, well, 3 plus 3 is 6, and then 6 times 3 is 18. However, that is not the answer that we get, right? Remember, because of PEMDAS, and we're talking about the order of operations here, multiplication is done before addition. And so we would say 3 times 3 is 9, plus 3 is 12. And that's how we end up with 12. Now, if I wanted the addition, for whatever reason, to take place first, what I could say is 3 plus 3, and I'm going to put that inside parentheses, because remember, anything in parentheses is going to be evaluated first from the Python perspective. And so 3 plus 3 times 3, that's going to give me 18. And again, you can experiment with this and check different things out, but PEMDAS, right? Remember PEMDAS. All right, so that was kind of a quick review as to how Python can be used as a basic calculator. And now we're going to take a look at one of the most popular data types with Python, and that is the string. Now, if you're in the virtual machine, and I am on a Mac using VMware Fusion, but I'm on a Mac is the key here. If you type Control or hold down Control and L, that will actually clear the interactive interpreter screen. And it does the same thing on the Mac in a different window. If I was to come back to my main window, and let's take a look at Secure CRT here. If I was to say Python 3, and you can see here I'm running version 3.11.1, so I'm running a very current version of the Python programming language. Again, if I was to just type some things in here, right, we get some error messages, and I decide I want to clear the screen, Control L is going to work, right? So again, I am on a Mac. On Windows, I believe it might be Control I. Maybe you can help me out in the comments below. And if you can figure that out, go ahead and type that in. All right, so we are back here, and we're going to take a look at strings. So what is a string? Well, I'm going to go ahead and say hello world, similar to what the lab is showing. Again, we're focusing here on part 2 in the lab. And that is a string in Python. Now, interestingly enough, this is also a string in Python. So I can use double quotes, I can use single quotes, I can even use triple quotes. Now, a quick note on the triple quotes, or the triple single quotes, or triple double quotes, but a quick note on this is that the triple quotes are typically reserved, and I should say more often than not, these are reserved for what's called a doc string, DOC string, right? A doc string. And you could think of it as something similar to maybe a man page in Linux, or something that's going to help other programmers out with comments inside of your functions, right? As one example of how you could use the doc string. So when we're writing code, we're not going to be using the triple quotes in the things that we'll be doing initially. When we get to functions, we'll talk about it. But for now, we're going to stick to the single and double quotes. Now, one of the questions that typically comes up is, well, is one better than the other, right? Is this example here at the top, hello world, should I do it like that or should I do it like this? And the rule of thumb is consistency. However you're going to do it, make sure you're doing it the same way every time. And I typically use single quotes when I'm doing demonstrations, but the double quote use case is right here. And this is, the sentence won't make any sense here, but I can't and I won't and don't. Now, you'll notice what is interesting about this sentence right here that I've got, the string, I should say, is we've got 3 instances of the single quote. Now, I've enclosed the entire string in double quotes, and so everything is going to work great. And that's a great use case for using the double quotes, is if you don't want to have to escape those single quotes. And let me show you what I mean and what's going to happen here. Now, this is going to throw an error, because Python's going to look at this and the interactive interpreter is going to read it, it's going to evaluate it, and then it's going to print an error message out, because Python is going to think that this right here, I can, closed by that individual single quote and started with this single quote, that string that's enclosed there, that's everything, right? And all this other stuff here is uninterpretable. That, in other words, Python's going to look at that and say, well, I have no clue what you want me to do with all that, because I'm just looking at the first set of single quotes and what's enclosed inside those. That would be the string. So we're going to get a caret underneath that T, that very first T here in can't, and then everything else behind it is going to be interpreted as an error. So Python reads, evaluates, prints out what it evaluated, which is, hey, I don't understand what you've got going on here, and then it's going to loop, and we come right back. So we get a syntax error, invalid syntax. The escaping that I was talking about is if you really like typing the / character and you're really good at it, then maybe single quotes is the way to go for you here. However, I am not a fan of having to do that. By escaping those single quotes, what I'm saying is that the special functionality that these have in Python, meaning they're enclosing a string, is I'm not interested in that functionality here. I don't want it to be interpreted by Python. And as you can see, Python's going to go ahead and run, and it's not going to give us the error. Because again, we've escaped that special functionality. So again, it's going to come down to what you're most comfortable with and what you seem to like the best and what's easiest for you. Again, you'll see me use single quotes a lot. However, if I've got something where I'm typing a sentence like, I can't, I won't, I don't, then what I'm going to go ahead and do is I'm going to enclose it in double quotes, right? Now, remember that the REPL, right, read, evaluate, print, and then loop, it's printing what we're typing here. Now, there's a built-in function in Python, and it's the print function, right? Now, that's the function. You'll notice if there's nothing inside the parentheses, it just prints a blank line. And in your programs, you may want something like that to happen. Now, I can also put strings, I can put strings inside of that function. Now, in your programs in Python, and when I show you the Integrated Development Learning Environment, or IDLE, you're going to notice that when we create a file, that this is what we would want to do. Now, it's going to work just like it did earlier on in the interactive interpreter without the print function, because REPL, right, read, evaluate, print, and then loop, is printing for us. That's in the interactive interpreter where, again, I don't need to put the print function in here. It's going to print it out for us, right? Again, when we're doing files, when we're creating programs in files that we would save with a .py extension, then we would want to go ahead and use the print function. And we have to use the print function if we're trying to print in a file, right? So how do we get out of here? Well, there's a couple ways we can get out of here. I could type quit, and that's a function, or I simply just do Control D. And then that brings me right back here. Now, a quick note, everything we just did here in that interactive interpreter session is gone. In other words, once I start the session, everything I'm doing is kind of still in the session if I've created some variables and things like that. But once I quit out with either the quit function or Control D, everything that was there is gone. So this leads us to our next exploration here, and we're going to now take a look at VS Code, and we're going to create a little program in the virtual machine. So let's move over to the virtual machine, and let's take a look at VS Code. Oh, sorry, in the virtual machine here already. Let's fire up VS Code. So here you can see you've got Visual Studio Code. Now this is free to download and use on the Mac as well as the Windows platform. So like I said, you don't have to have the virtual machine to complete these first two labs. However, I would highly recommend that you do. All right, so let's fire up Visual Studio Code. We should get a really nice sort of welcome screen here. You can see this tab is opened up. I could close it down. We'll leave it open here. And I'm going to create a new file. Now, why are we using VS Code? Well, we're using VS Code so that you don't have to use VI or Vim, the visual editor that is native on Linux, because the learning curve is very steep there. And this is a great way to be able to sort of just type your code in and then run your code. So let's see what that looks like. I'm going to click on New File. You can see here it says Untitled. Let me save this, right? So I'll say File Save. Now, in the lab, it has you save it down what I'll refer to as the rabbit hole, which is a path that runs all the way down into the labs, to the DevNet source, to Python, and then you put this practice program in there. I'm simply going to leave this right on the desktop, right? And we're just going to call it Hello World. And let's get up here and we'll take away the untitled one. We'll call this program Hello World.py. And then I'll come down here and I'll simply click on Save. Now, a couple things are going to happen. You're going to notice it says Hello World.py, right? So if I'm in this tab, right, and I can come over to this tab if I'm programming here. And pay attention, when you start the virtual machine up, if on these little four squares here, you see an indicator with a, I think it's a blue circle with a white number 1 in it, you may need to enable extensions in order to have VS Code or Visual Studio Code recognize right away that, hey, this is a Python program and I'm going to run it as a Python program when you tell me to run it. And that would be in the extensions. If you see a little blue 1 there, or a blue circle with a white 1, that's what you're going to want to do. You can also see we've got the version of Python down here in the lower left-hand corner, Python 3.8.2 64-bit. So in a file, I want you to watch what happens. I'm going to say hello world, and now this may run, but my guess is we're going to see an error of some kind. So if I came to run and said run without debugging, down here, you're going to see the output, right, of what would result as the output. And you'll notice it doesn't print hello world. Now, we also don't receive an error, but it doesn't do what we want it to do. We want it to print the message out. And so I'm just kind of showing you this is why in a file, right, not the interactive interpreter, but in a file, we want to make sure that we are using the print function when we want something to print. So I'm just going to simply say File Save. And the one that was right there, so if I was to change something, right, if I change the program, you're going to see that we end up with that little 1. Now, that's the same one that you would see down here if you need the extensions enabled. However, what this means here is, hey, you need to save, right? It's an unsaved file. We've made changes, and you might want to save those changes. So I'll just go ahead and click File Save. You could always do the Control S, but I'll just do it from the menu for now. And so now let's rerun. And what I really like about Visual Studio Code is it gives me my CLI right down here, right, on this virtual machine. So I'm going to go ahead and click Run without debugging. And that is what we were looking for. We wanted to print hello world, and it did. Now, down here, you can see I can even type in ls, and there is the program that we're actually running. You can see we've got some directories that are in here. I could even type in ls-l or ll, which is the alias for that, and see what's in the directory, which we did earlier. I can clear my screen. So again, we basically have a CLI terminal window down here that we can work in and that we're going to see the result of our program in when we go ahead and run that program. And that is really VS Code in a nutshell. Now, you'll remember I recommended that you don't need the VM to complete the labs. What we could do is if I was to pull up my Firefox web browser, now I'm back on my Mac. If you were to go to python.org and come to the downloads here, you can see that Python version 3.11.2, this is the most recent version of Python, or I should say CPython, and we'll get into that a little bit later. It's some semantics around the programming language in which Python is written, and so here it's written in the C programming language, and this is going to do exactly what we need it to do. But what you can do is if your OS is Windows, it's auto-magically going to identify your OS, and it's going to allow you to download that recent version. And you can see right here, I now have it as this .pkg file, and I can install it. And once I install the program, a window is going to pop up. In fact, let's go ahead and I'll click on this, and you can see it's going to walk us through the install. And this is 100% free, and you can download the Python programming language. I'm going to put my password in here. And I think I may have just mistyped it there. Hold on one second. And this is going to, within 30 seconds, I'm going to have the latest and greatest version of Python installed. But more importantly, and the behavior on Windows is very similar, you're going to have a window open up, that window right there. And this is what we're looking for. Now, you can drag and drop this over onto your dock. You don't have to. But if we were to open this by simply double-clicking on it, it's going to open up the Python Integrated Development Learning Environment, right? Or IDLE. And what is IDLE? Well, IDLE is a fantastic tool that gives me, right here in this window, the interactive interpreter. And so what can I do here? Again, it's Python. I can go ahead and do some math equations here if I needed to. I could type some strings in here, and I'll just say hello, or hello if I was a cat, right? I can type in some strings here. It's going to read, evaluate, or read, execute, or I like evaluate. Some people say execute, but it's read, evaluate, print, loop. And then it's just going to simply loop. We're in the interactive interpreter. Now, more importantly, you might be saying, well, okay, well, how do I create a file? Well, it's easy. You just come up here to File, New File, and here is my new Python file. And so let me go ahead. These are comments, right? The pound sign. I usually use 2. You can use 1. It doesn't matter. You can have a variable amount. But I usually use those and put some comments in my program. But here we're going to say print, and I'll say hello world. And what you're going to notice is this is just like the VS Code editor. Now, how do we run this? Well, you can hit F5, or I can come up here and say run module. So we'll say run module. It's going to tell me, hey, I can't run it. It needs to be saved first. And so we need to save this. And I'll just simply call it howdy.py. Again, there are some instances where you don't use the .py at the end of a file that has some Python code in it, but those are going to be kind of outside of our scope right now. So for now, get in the habit of always putting a .py at the end of your Python file. And then right over here, it's going to go ahead and run the program and put the output for the program that was over here in our interactive interpreter session, right? So that's how quick and easy and accessible it is to get the Python programming language. All right, well, that is going to conclude this video tutorial kicking off Lab 1.3.3 Part 2. For Part 3 of this lab, which is going to be our next video, we're going to do a much deeper dive into the different data types. We're going to look at integers, floats, strings. I'm going to show you some tips and tricks as to how you can validate that you're working with the data type that you think you are. I'm even going to talk about tuples, and some people call them tuples. I like tuple. And I'm going to show you some tricks with that and some errors to avoid. All right, well, thank you guys so much for watching. I really hope you're going to enjoy the course this semester. This video should get you up and running with Lab 1.3.3. And as always, thank you for watching, and I hope to see you in the next video.